Does CPU matter when it comes to LLM inferencing? I've got two PCs running Windows 10, 32GB of RAM and a modified 2080 Ti with 22GB VRAM. The older one is an Intel i7700 quad-core CPU 7th gen. The other newer one is the Intel 12100F quad-core CPU. Both GPUs are capped to 90% power limit. I have seen almost zero performance difference, so that's my baseline. They're both running Gemma 4 26B Q4, which is slightly under 14GB in size, with 32K context. Let's start with a coding task to create an atom and element simulator. The faster CPU clocked in at 132 tokens per second, while the slower one ran at 131 tokens per second. Only a 1 token difference. Next, we'll do a writing task, which is usually slower than the coding tasks, probably because code has large chunks of repeating and predictable structures. Okay, the faster CPU did 104 tokens per second while the slower one did 101. Not much of a difference again. A bigger gap, but still very negligible. So for non-coding tasks, we can start to see a small difference of 3 tokens per second, but still pretty negligible. Now let's do an experiment with the best bang for the buck overclocking or underclocking setting you can do, which is power limiting or capping the power usage of the GPU to only 75%. Personally, I found this to be the sweet spot, huge gains in power efficiency for minor hits to performance. Let's do another coding task by creating a Tetris game. The faster CPU did 124 tokens per second while the slower one did 120. Although we did see some performance differences between the newer and older CPUs, it was a very small and minor difference. So if you've got some older hardware, feel free to use it for inferencing, as it won't really make much of a difference for LLMs. This may not be true for other types of AI workloads. For example, speech-to-text processing using Whisper, the CPU will make a huge difference. Okay, hope you found this useful, and remember to go ahead and power limit your GPUs. Save the environment and some money as well. See you next time.